In our previous lessons, we have learned how to draw the plan and the front elevation of an object to scale. We learned how to determine the correct measurements for our drawings based on the given scale. For example, the plan and front elevation as viewed from X of the object shown are using a scale of 1 to 10. This means that 1 centimeter in the drawing represents 10 centimeters on the actual object. Besides the plan and the front elevation, the side elevation is also needed to help us describe a solid object visually. So in this lesson, we are going to learn how to draw the side elevation of an object to scale. Example 1. Given the solid object with a 35 centimeters high triangular prism, draw the side elevation of the object using a scale of 1 to 10. Let's first find the measurements in the drawing that represent the actual measurements on the object. A scale or a ratio of 1 to 10 is equivalent to 1 over 10. Hence, multiply each measurement by 1 over 10 and we get the measurements for our side elevation. Next, we draw the side elevation of the object as viewed from Y. Complete the drawing with the given labels and the measurements that we had calculated. Example 2. Given the solid object, draw the side elevation of the object using a scale of 1 to 3. First, calculate the measurements in the drawing that represent the actual measurements on the object. A scale or a ratio of 1 to 3 is equivalent to 1 over 3. Hence, multiply each measurement by 1 over 3, and we get the measurements for our side elevation. Next, we draw the side elevation of the object as viewed from Y. Finally, complete the drawing with the given labels and the calculated measurements. Example 3. Given the solid object, draw the side elevation of the object using a scale of 1 to 5. As before, calculate the measurements for the drawing first. A scale or a ratio of 1 to 5 is equivalent to 1 over 5. Hence, multiply each measurement by 1 over 5, and we get the measurements for our side elevation. Then, we draw the side elevation of the object as viewed from Y. Complete the drawing with the given labels and the calculated measurements. Example 4. Remember this object from our previous lesson? Besides its front elevation that we had drawn, we are now asked to draw its plan and its side elevation using a scale of 1 to 50. Let's use the method where we use projection lines for our drawings. The scale or ratio given is 1 to 50, which is equivalent to 1 over 50. Hence, after converting the measurements from meters to centimeters, multiply each measurement on the object by 1 over 50, and we get the measurements for our plan and elevations. As Y is to the right of X, then our plan and front elevation will be in the left column. We will draw the plan first. The measurement for IJ and LK are not given, but we know that MI is 2 meters. So, the length of IJ can be found after we have drawn the front elevation. Let's do that now. MI is 4 centimeters in our drawing, so this is the length of IJ. By drawing a projection line from the front elevation to the plan, we can now draw line IJ on the plan. Complete the plan and front elevation with labels and measurements. Next, we draw the side elevation as viewed from Y. Complete with labels and measurements. Example 5. We have another prism here on a horizontal plane. We are only asked to draw the plan and the side elevation. Only this time, the side elevation is on a vertical plane, parallel to the diagonal, AD. The scale or ratio given is 1 to 12, which is equivalent to 1 over 12. Hence, multiply each measurement on the object by 1 over 12, and we get the measurements for our plan and elevation. We will draw the plan first. Include the labels and the measurements in it. Next, we draw projection lines from the plan perpendicular to AD. Use either your protractor or your set square and ruler to make sure that the lines are perpendicular to AD. Then, we draw the side elevation. Measure 8 centimeters for the height. Complete the drawing with its labels and measurements. In today's lesson, we learned about how to draw the side elevation of an object by using a given scale. The side elevation of an object is its orthogonal projection on a vertical plane as viewed from a certain angle. When drawing the side elevation of an object, using a scale of 1 to x, we must make sure that 1 centimeter in the drawing represents x centimeters on the actual object. For example, if a scale of 1 to 20 had been used to draw the side elevation of the cube as viewed from y, then 1 centimeters in the drawing represents 20 centimeters on the actual object.